Welcome back students to the next video. The topic for today is post-fertilization events. As you can understand, this is towards the end of the chapter. So the previous topics, sexual reproduction in flowering plants, I have been making a set of videos. Please watch all of them so that there is a continuity. If you are directly here, you may not be able to completely follow. However, I'll try to make sense for you. If you haven't watched the previous videos, please do. Otherwise, also if you're in a hurry trying to understand this topic, let me try my best to make you understand. All right. So from the previous, something called as post-fertilization, double fertilization that happened in a flowering plant. Right. So what is double fertilization? Two fertilizations happened. Where did all that happen? One over here in the polar nuclei, one fertilization or one fusion happened, resulting in triploid nucleus. Other one was over here with the egg. So egg and the male nucleus fused. Here polar nuclei, two were there, one male nucleus fused. That much happened in double fertilization for those who missed that video. Alright. Now we are understanding what is meant by post-fertilization events. So you know what is meant by post-school activity, after school activity. The same way post-fertilization events mean after fertilization, what all are the events that are happening. Alright. So fertilization has resulted in a triploid PEN. I hope you know what is PEN. Primary endosperm nucleus. This is over here. And the other is zygote. Zygote is by the fusion of the egg with a male nucleus. And this is diploid. That is 2N. This much has happened. Now, after this, what all are the developments? Those are called as post-fertilization events. And we can categorize that as formation of endosperm and formation of embryo. So, which one among this happens first? That's another question. It is the development of the endosperm that happens first because endosperm gives nutrition or food for the developing baby plant, which is the embryo itself. Alright. So, you'll get this question in your question paper. Endosperm development precedes embryo development. Why? Because endosperm provides nutrition. One single line and you get 2 marks. So please don't miss that. Okay, going ahead. From where this endosperm is developing and from where embryo is developing. From the PEN, what is PEN? Primary endosperm nucleus forms this because it's endosperm, isn't it? Nucleus from where? Okay. So around the endosperm nucleus is the endosperm cell. That much you can guess, right? Primary endosperm nucleus is inside the PEC, which is primary endosperm cell. In this, few developments are going to happen. So that is what we will be covering first. So what happens over here? Right now, how is the cell looking? The cell is looking somewhat like this. Alright. The cell has a nucleus which is basically a triploid, like so. That's it. Now this undergoes mitotic division. You know, in a mitotic division, just the nucleus is dividing into two, right? That's it. Followed by the division of the cytoplasm. But in this case, in case of endosperm, that is not how it works. Only the nucleus will divide into two. So you have two nucleuses right now. This two of them is going to again divide into make itself 4. The 4 will become 8 and so on. So at one point of time, there will be one cell membrane inside which lot of nucleus will be there. That stage we're going to call as free and nuclear endosperm. Free nuclear endosperm. This is what is the tender coconut water that you're drinking. It is the free nuclear endosperm you're drinking. And you know, in the tender coconut, what happens? After some time, the liquid part kind of starts becoming thicker and you find a whitish kernel which you can eat coming up. Alright. Where did that come from? It is basically this free endosperm nucleus like so. So many are there, right? So many are there. I'm not making it into 3 dots because it is understood all of them are 3N or triploid. What happens is each of them will start developing cell membrane around it. So they become proper cells. Those at that point we don't call that as free nuclear anymore. Alright. Okay. So at that point we call them as cellular endosperm. Cellular endosperm. Okay, so that's about endosperm development from this. That's all you should know. What is free nuclear endosperm and what is cellular endosperm. What about the embryo? From where is it developing? Embryo is basically the baby plant, like I already told you. Where is that developing from? Let's see. Okay, so the egg and the male nucleus have joined or fused to form something called as the zygote. Zygote is diploid and zygote currently has is a single cell with only one nucleus which is diploid. What happens to it? It divides into two, two into four, four into eight, and so on. It starts developing. All right. That development takes certain shapes. All right. If it is take first stage, in the first stage, it takes a round globular structure. Globular basically means something like a sphere kind of round structure. That's the first phase. Second phase, it goes into this part becomes heart shaped. Third phase, it becomes the mature embryo. Here, mature embryo, this one. All right. Okay. So these are the stages of development of embryo. So this much you should know with respect to post-fertilization events if they ask you to write. Alright. You should also know the structure of a embryo. So let's see what is the structure of an embryo now. Yeah. Coming to the structure of embryo, what are the things to remember? As you can see, the same picture is shown in your NCERT book upside down. Whatever these cotyledons are, same is over here. Okay, so we look at this picture and try to learn the structure of embryo. So what all are there in it? First and foremost, there is an embryonal axis and there are two cotyledons, 1 and 2. This is the dicotyledon embryo. Alright, so there are two cotyledons. The structure that is above the cotyledon level, this part over here, we will call as the epicotyl, and below this level, this part onwards, we call as hypocotyl. Even though the arrow is here, this part is called as the hypocotyl. In the epicotyl, it ends with the leaf primordia called as the plumule, and this part, the hypocotyl, ends with the radicle or what will become the root at a later point, and therefore it has a root cap as well. That's all that you need to know with respect to dicotyledon embryo structure. When it comes to monocotyledon, it's somewhat same. However, a slight bit of changes there. That is, you can see that there is only one cotyledon. The same structure, it is showing the opposite direction. That's all. This one, imagine it being like this. That's all that is to this structure is. Alright, so this is your cotyledon. Only one cotyledon. The other structure is the embryonal axis or the embryo. Now you can see there are other labels on this. What are these labels? Let's see. As you can see here, then cotyledon part is labeled as something else. So in grasses, the monocot grasses, cotyledons are named as scutellum. And when we look at the embryo will have a sheath on both ends. The sheath that is there near the plumule starting with P, plumule, the structure is called as coleoptile with a P. And here, the root part, radical part, the sheath that covers the radicle, it is called as coleorhiza. So remember which one is coleoptile? Tile is the one where plumule is, P is present, and wherever the radicle is there, R, the sheath is called as coleorhiza. That's the only thing that you have to remember that is different from the dicotyledon embryo. I hope it is clear. Video useful. So if you subscribe and please share with your friends as well. for all your doubts, please connect with me through the comment box. Thank you.